Welcome to FEMSA Edu Consultancy channel. Today we'll be looking at another topic on indices and logarithm. And we'll be solving questions across the various institutions that we could access their past question for now. Okay, we are taking a question from UNN, that's University of Nigeria. Alright. Solution now. This question is under we call it exponential equation. Okay, it's under indices. How do we solve this problem? Don't forget that we are just solving questions, so we want to leverage your foreknowledge of indices and logarithm. That means that prior to this time, we expect you to know all the laws that are applicable in solving any question on indices and any question on logarithm. Okay, so that's why we are not going through the laws of indices again. So we just want to apply the laws now to solve this problem. All right, solution. Now we have been given, don't forget it's an objective question. You are not to waste time on it, but my explanation is what may make the solution look as if it's longer, but it's not. It's just that I want you to understand, especially if you are finding this topic a little bit challenging. Alright, so for this exponential equation, if we apply our law of indices to this, we remember that there is one of the laws that says that, which you call the first law, something like this, that if you have an exponent, or we have an index notation x raised to power a, and it is multiplying another index notation x raised to power b. Once you observe that the bases are the same, okay, you can take one of the bases which is the same and add the powers together. One of the things I need to show you from here is that if x raised to power a multiplied by x raised to power b can give you x raised to power a plus b, okay, then it means that x raised to power a plus b can also be the same thing as what? X raised to power a times x raised to power b. So I'm using this particular law to rewrite this now, okay? This one must have come from what? 2 raised to power 2x times 2 raised to power 3. Do you agree with me now, according to that law? Then minus 33 multiplied by 2 raised to power x plus 4 equal to 0. Okay, so the next thing is that I am trying to rearrange this equation in such a way that I will find a common or a repeated index notation. Alright, I've seen 2 raised to power x, and I can spot 2 raised to power x around this particular term. That's why I decided to split and to see if I could get another 2 raised to power x from here. Then I do know there's another law that's like the power law, that you have x raised to power a raised to power b. We do know that this one is the same thing as x raised to power what? A multiplied by b, okay, which is the same thing as what? X raised to power ab. Alright, adding them, multiplying them together. That means that if this is equal to this, then I can rewrite this too like this, okay? So look at it. This is 2 multiplied by x, which is 2x. I can rewrite it as 2 raised to power x or raised to power 2. I will also be correct if I write it as 2 raised to power 2 or raised to power x. It's also the same thing, because this and this will give you the same thing as this. But which one of them will make me get an index notation that will look like this? You will realize that it is this. Okay, because I can see 2 raised power x here, I can see another 2 raised power x here. That's why I'm choosing this instead of this. Okay, now So multiply by 2 raised to power 3. And 2 raised to power 3 is what? I think you know that that's 8. Minus 33 multiplied by 2 raised to power x plus 4 equal to 0. Now, once you have been able to do this, then the next thing we have to do is to look for another variable or a letter that we can use to represent 2 raised to power x, so that you can properly see that the equation that is appearing to you here is actually a quadratic equation. Okay, so now I can say let 2 raised to power x be equal to another variable, say p now. So anywhere I see 2 raised by x, I can introduce p. So it means that this expression, it implies that we have p squared multiplied by 8 minus 33 multiplied by p plus 4 will be equal to 0. I hope you are getting it. So that this will become 8p squared minus 33p plus 4 equal to 0. Alright, now my duty now is to solve this problem. So I am to solve this quadratic equation. Alright, so how do I solve this quadratic equation? Because you are looking for you are looking for two factors now, that when you multiply those two factors, and it has to be factors of the product of 8p squared and plus 4. But when you look for those two factors, when you multiply them, it will give you plus 32p squared. And when you add those two factors together, it must give you minus 33p. Alright, and we are to now use that to solve this equation. But the shortcut is this: anytime you are solving a quadratic equation, especially for a multiple choice question, nobody is interested in the approach or the steps you took to get those questions, to get the answer. So all I just need to tell you is that whenever you look for those two factors, I believe you know how to solve quadratic equation by factorization method. When you get to that aspect where you have to look for the two factors that can replace the middle term, when you get those two factors, ignore the variable, just deal with the numbers. Okay, now what you do to those two factors which carry the signs along is that reverse the sense of the sign. Alright, once that is done, divide the result by the coefficient of the variable with the highest power. In this case, the variable with the highest power is p squared. And what's the coefficient? 8. So whatever be the two factors that can replace this, alright, use 8 to divide them. Whatever you get, reverse the sign. Or you first reverse the sign, then divide by 8. Whatever you get is your final result of this equation. You may not necessarily need to solve further. What that means is that if we are to get our factor, you will realize that the two factors that will replace minus 33p from the product of 8 and 4, which is 32p squared, is both minus 32 and minus 1. Minus 32p and minus p. When you multiply them, you will get plus 32p squared. When you add them, you will get minus 33p. Now, what I am saying is that ignore the variable now, the letter involved. What are the factors? The factors are minus 32 and minus 1. Okay, because minus 32 minus 1 will give us minus 33. Now, those two factors you have gotten, can you reverse their sign? Once you reverse the sign, you get 32 and 1. It's no longer minus 32 minus 1, it's now 1 and 32. That 1 and 32, use this coefficient of p squared, which is 8, to divide the two of them. That means 32 over 8 and 1 over 8. What is 32 over 8? That's 4. What is 1 over 8? Is still 1 over 8. That shows that the solution to this quadratic equation is just 4 and 1 over 8. Alright? When I get to this part, I don't need to solve anything. I will just get the two factors, reverse the signs, then use the coefficient of p squared to divide the results. And whatever I get is my final answer. That is for the quadratic equation. Are you getting it now? But let's solve it just for you to see the approach. this equation becomes, we have 8p squared minus 33p can now be split into 2, minus 32p minus p. Alright, then plus 4 equal to 0. I got this minus 32p and minus p from multiplying the first term and the last term together. That will give you plus 32p squared. And the two factors of p squared that you will need is p, or p and p. And for 32, what are the two factors of plus 32? Such that when you add them together, it will give you minus 33. You will realize that it is 32 minus 32 minus 1. Okay? Minus 32 minus 1. If you add them, it will give you minus 33. And when you multiply minus 32 with minus 1, you get plus 32. Do you see that now? And once you match this now, it becomes the two factors you can use to replace the middle term. Hope it's clear. So we have that. That's why instead of saying minus 1p, it's the same thing as minus p, because the coefficient of p there, alright, is still minus 1. So now we can now factorize by grouping. So between this and this now, what is common? You realize that 8p is common. I'll be left with p. Then here I'll be left with 4. Then minus 1 will be common. Then I have minus 4 equal to 0. The sign of this is reversed because I factored out minus 1. Okay, so then I will have what is common between this expression and this expression is p minus 4. And what will be left here is 8p. What is left here is minus 1. So I can group this now equal to 0. So that if the product of this and this gives me 0, it shows that one of them is 0. That means this is 0, or 8p minus 1 is 0. So that p here will become what? 4, or p here in this case, transfer minus 1 to the other side, or add 1 to both sides. Then that will give you 8p equal to 1. Then divide both sides by 8 to get your p. So that's going to give you 1 over 8. Now, if you look at this, you might jubilate, okay, as if you have gotten the answer. No. If you go for this, you will see option C is smiling at you, and you will be wrong, because they didn't ask us to look for p. We were the one that introduced p. Okay, we were to find the values of x, not p. But don't forget that we represented 2 raised to power x to be p. So you have to recall that statement. So recall that 2 raised to power x is equal to p. Alright? When p is equal to 4, what do you think will now happen? It will now imply that 2 raised to power x will become 4. Alright? And what is 2 raised to power x? 4 is the same thing as what? 2 raised to power 2. Okay? Now check it. If 2 raised to power x is equal to 2 raised to power 2, what can we infer from here? I can infer from here that my x is equal to 2. Don't make the mistake. 2 did not cancel 2. Alright? This is under equality of indices. Once the bases are the same, we can infer that the powers 2 are the same, not 2 cancel 2. If you say 2 cancel 2, you are simply saying that 2 is a common factor that you can use to divide both sides, and that the result of division is not mathematically correct, because if you use 2 to divide this, it's supposed to give you 2 raised to power x minus 1. It will not terminate these 2. I hope you get that now. So what we do is to apply the rule of indices here. The bases are the same, then we can infer that x, which is the power, the 2 powers, 2 will be the same. Alright, so that's how we got this. Now, on the other hand, when p is equal to 1 over 8, what can we also infer from here? 2 raised to power x will become what? 1 over 8. Okay, and what is 1 over 8? Do you know 1 over 8 is the same thing as, I can write 8 as 2 raised to power 3, isn't it? So that means that this same person here is same thing as 1 over 2 raised to power 3. And how can I rewrite this? You will realize that I can say that 2 raised to power x here, I can write this in index notation as 2 raised to power minus 3. So what do you observe here again? 2 cancel 2 abi? No, 2 is not cancelling any 2. The 2 bases are the same. So what can I infer? I can infer that what? The powers 2 will be the same. X will be equal to minus 3. So I have the 2 results. X is equal to 2 or x is equal to what? Minus 3. So which of the options now? 2 and minus 3. That is option A. I hope that is clear. Okay, so how do we solve this problem now? You need not to panic. We'll still make use of the rules of indices, okay? Now look at it. We are to look for fifth root. So this means fifth root of 243 raised to power minus 1 x raised to power 5. Do you know that this is the same thing? Remember, there's a rule that nth root of x is the same thing as what? X raised to power 1 over n. Do you remember the rule? So we can, if this is equal to this, that means I can write these two like this. Okay? So now that means I can write this nonsense following that rule as what? 2, 4, 3 raised to power minus 1, minus 1, then x raised to power 5, all of these raised to power what now? 1 over 5. Do you get that now? Okay, what other thing can I do again? Do you notice that I can simplify this guy? This 243 is the same thing as what? 3 raised to power 5. Because I know 3 times 3, that will give me 9, times another 3, that's 27, times another 3, that's 81, times another 3, 243. Okay? So now, this has been changed to this, then raised to power minus 1, then x raised to power 5, then everything raised to power 1 over 5. Alright? Now, you remember another rule that I just stated that in the other solution. X raised to power a, you have in this index raised to power another, this index notation raised to power to another power. This will give us what? X raised to power the product of the powers. Alright? So the same way, if this is going to give us this, that means these two can also give us this. So from here, I can write this nonsense as what? 3 raised to power 5 multiplied by minus 1. Okay? That's 5 multiplied by minus 1. And 5 multiplied by minus 1 is what? Minus 5. So I can write this as this. Then x raised to power 5. Everything raised to power what? 1 over 5. Are you getting it? Now it has not ended there. This one here, you remember there's another rule. Okay? Where if you have x raised to power a, or let me say xy, all raised to power a, do you agree with me that I can write this as x raised to power a multiplied by y raised to power a? Here a, can be given to the two bases. Alright? That means we can have x raised to power a multiplied by y raised to power a. Okay, it's a rule. So if this is equal to this, then these two can also be equal to this. That shows that this 1 over 5 can be applicable to the two of them. What would that give us? 3 raised to power minus 5, all raised to power 1 over 5, times x raised to power 5, all raised to power 1 over 5. Now, I can now fall back again to this rule that x raised to power a raised to power b gives me what? X raised to power a times b. That means I can write these two as these powers two can multiply. That means I can have 3 raised to power minus 5 multiplied by 1 over 5. Alright, times x raised to power 5 multiplied by 1 over 5. So that this 5 can terminate this 5. What do I have left? 3 raised to power minus 1. You get it? Then times this will give me what? X. Then you remember that there's another rule where the index is a negative value, where you have x raised to power minus 1. Okay, this will give us what? 1 over x. And where you have x raised to power minus n, what does this one give us? 1 over x raised to power n. You can remember. And where we have a fractional base, x over y, all raised to power minus 1, what will this give us? Just invert the base, y over x, that's all. And where it is x over y, all raised to power minus n, just invert the base, take the reciprocal of the base. That's what the negative sign indicates. So you have y over x, then all raised to power n, the negative sign is gone. You use the negative sign to take the reciprocal of the base. Alright? So in this case, this one cannot be written as what? This 3 raised to power minus 1 will now be written as 1 over 3 multiplied by what? X. And this x is same thing as over 1. So if you multiply the numerators, you have what? X. X 1 times x is x. And 3 times 1 is 3. So what do you have? X over 3. That's option A. But you have to be very careful so that you don't pick 3 over x, or in the bit of rushing you don't go and pick minus x over 3. I hope that is clear. Okay, so this is another question, the same year, question number 2. It says, without using tables, evaluate these. So how do we evaluate this nonsense? Solution. So we have 125 raised to power minus 1 over 3 multiplied by what? 0.49 raised to power minus 1 over 2 multiplied by 0.01 raised to power 1 over 2. Minus 1 over 2 rather. So this is same thing as I can rewrite this guy as 5 raised to power 3. Or then this all raised to power minus 1 over 3 multiply, I can rewrite this guy, okay, as 49 over 100. Do you agree with me? Okay, because this is a decimal fraction, so I can write this as 49 over 100 all raised to power minus 1 over 2 multiply by, I can rewrite this guy too as what? 1 over 100, 1, 2 decimal places, all raised to power minus 1 over 2. So what other thing do I need to take note here? I can now write this as what? I can write this as what? 5 raised to power 3 multiplied by minus 1 over 3. Do you agree with me? I'm applying the law of indices here. Times, I can write this guy too as what? Because of this negative sign, there are two ways. Alright, I can write this 49 over 100 as 7 square over what? 10 square. Okay, so this 7 square over 10 square, I can combine them to be 7 over 10 all square. 7 over 10 all square. Do you agree with me? And if we have this, then all raised to power minus 1 over 3, it will make this multiply this. 5 raised to power minus 1 times 7 over 10 raised to power minus 1 times 1 over 10 raised to power minus 1. So from the law of indices, I can say that 5 raised to power minus 1 is the same thing as well, 1 over 5. Okay, and this one, from the law of indices, I can say this is the same thing as well, 10 over what? Over 7. I hope you got that. Alright, so then this one too will become what? 10 over 1. You remember that law that I said when you have a fractional base, all raised to power minus 1, what would this one? The negative sign indicates the reciprocal of the base, which is what? Y over x. Then everything raised to power 1. And because it is raised to power 1, it's going to be the same thing. Y raised to power, y over x. So the same way, and the result of this will become what? 5 here 1, 5 in this place is what? That's 2. So I will have 20 over 7. Oh, I'm sorry, I didn't give the option. Option A is 7 over 20. Option B is 20 over 7. Option C is 5 over 7. Option D is 7 over 5. Of course, which of the options? That's option B. Alright, so it's as OAU 2009, question number 3. This is another question on exponential equation. So the same approach we use the other time is what we are still going to make use of. So we have been given 3 raised to power 2y minus 6 into 3 raised to power y equal to 27. So we have to find y. What do we do in this case? So we can rewrite this as 3 raised to power y or raised to power 2. We chose this so that what we have here can be the same as this. It's also the same thing as 3 raised to power 2 or raised to power y, but that will not make us to have like term, the same index notation. Minus 6 into 3 raised to power y. I can bring this 27 here so that you have minus 27. I'll be left with 0 there. It's like subtracting 27 from both sides. Alright, from what I have done, I can see 3 raised to power y here, 3 raised to power y here. To make the work easy for me, I can now introduce, let 3 raised to power y be another letter p, for example. So when we substitute that, we are going to have what? P squared minus 6p minus 27 is equal to 0. Alright, so look at this now. This is already a quadratic equation. When you get a quadratic equation, you don't need to panic. All you just need to do is get the 2 factors that can be used to replace minus 6. Whatever those factors are, reverse the signs. Okay, and that's the answer, because there is no coefficient other than 1 for this p squared. So whatever the 2 factors are, just reverse the sign. That's the result of this quadratic equation. Okay, now, but let's find the factors. Of course, the factors are going to be what? Minus 9 plus 3. Reverse the sign. That means it's going to be 9 and minus 3. That's going to be the result of this equation, but let's verify. So we have p squared minus 9p plus 3p, then minus 27 equal to 0. So what can we do here? Then we can factor. We do factorization by grouping. So I can do that p is common to this, p minus 9. What's common here? I have 3 that is common. I will left with p minus 9 here. That will be 0. So what is common to this expression and this expression? You see that it is p minus 9. What will be left here? That's p. What about this? Plus 3. So I can group this, which is 0. So if the product of these two gives us 0, what does that imply? It means that one of them must be 0, or even the 2. So it's possible it is 9 minus p minus 9, that is 0, or it is p plus 3, that is 0. So I can imply from here that p minus 9 is equal to 0, or p plus 3 is equal to 0. So what does this imply? It means that p will become 9 when you add 9 to both sides here, or p will become minus 3 when you subtract minus 3 from both sides. Alright, they asked us to find the value of y. Okay, now you see 9, you see minus 3. There is no 9 here, so you are likely to think that minus 3 will be the answer, but you have to be very careful. We were the one that introduced p, alright, not them asking us to find the value of p. We are to find the value of y. So we will now need to recall that our 3 raised to power x was used to represented with p. 3 raised to power y was represented with p. So when 3 raised to power, when p is now equal to 9, what can we say? It implies that 3 raised to power y will become what? 9. So that 3 raised to power y becomes 3 raised to power 2. That's the index notation for 9. And I can conclude that since the bases are the same, definitely the powers too will be the same. Don't make the mistake. Alright, it is not 3 cancel 3. Do you get it? So we have y to become 2. Now, on the other hand, when p is equal to what? Minus 3, what can we say? 3 raised to power y equal to what? Minus 3. And you realize that I cannot write minus 3 as an index notation, you know, I cannot write minus 3 as an index notation. Do you understand now? As an index notation where the base is going to be 3. So the result of this does not exist, okay, I mean in a real plane or on a real plane. So in this case, y has no solution in this place now, okay? So okay, or we say that this y has no solution. On the real line. Okay, so the only solution is what? Y equal to 2. Except if we want to get the result of this in a complex plane. Alright? But on the real line, the value of y does not exist, for which 3 raised to power y is equal to minus 3. Hope it's clear. Alright, so our result is just 2. So this is another year, 2009, question 18 on logarithm this time around. Find n if log 4 base 2 plus log 7 base 2 minus log n base 2 is equal to minus 1. Alright, so solution. So what do we do here? We have log 4 base 2 plus log 7 base 2 minus log n base 2 equal to minus 1. All you just need to do is apply. We notice that from this now, we observe that the bases are the same. What do? We apply the law of logarithm to it. So that will give us log 4. Because of this addition sign, we multiply. Because of this subtraction sign, we divide by n. All of these to a common base 2. And you have equal to minus 1. So at the end of the day, this will give us what? Log 28 over n base 2 equal to minus 1. So you remember how we can convert from logarithm to indices. Okay? That means if log a base b is equal to c, then it means that b raised to power c is going to give me a. Or you simply say a equal to b raised to power c. The same way. That means I can write 28 over n is the same thing as what? 2 raised to power minus 1. So that this will now become 28 over n equal to law of indices 1 over 2. So what do we do here? We multiply both sides by 2n, which is the same thing as what you always say cross multiply. So this will now give us what? N equal to 2 multiplied by 28. And that's what? 56. Which of the option? Yay! I hope there is no mistake. So that's 56. So none of the options. I guess maybe this was supposed to be 56, but that's the answer, 56. Okay, maybe it's a typing error. So this is another question from IFE 2012. That's question number 2. We are asked to simplify this. Okay, so how do we simplify this problem? Alright, solution. So this is written as this same thing as 8 square root of n divide by m raised to power 3 over 2, everything raised to power 2, then multiply by 4 raised to power minus 1, m raised to power 4, m raised to power 4 divided by 2n raised to power minus 2. This is what we have. So we are to simplify this. So what's this going to give us? This is same thing as, I can rewrite this nonsense as 8, okay, and this same thing as n raised to power 1 over 2. I hope you agree with me. Divided by m raised to power 3 over 2, everything raised to power 2. Then this is same thing as what? 4 raised to power minus 1, and 4 raised to power minus 1 is same thing as what? 1 over 4. I hope you know. Then multiply by m raised to power 4 divided by what? 2 times this one is same thing as what now? N raised to power minus 2. Do you know that I can as well write this as this square is for all the three? So I can write this as 8 squared times, I can write this as n raised to power 1 over 2 all raised to power 2 divide, I can write this as m raised to power 3 over 2 all raised to power 2. Okay, then times, I can write this as 1 over 4. Do you know that this 4 can come down? So that I'll just be left with 1 times m raised to power 4 divide by this 4 comes down, you have 8 times this, then you have n raised to power minus 2. So from here I can see that the result of this guy, this one will become 64. This one will become ordinary n because these 2 and these 2 can multiply. Alright, then what about this? These 2 and these 2 can multiply. So I'll be left with m raised to power 3. I don't have to start writing that. I hope you understand. Then multiply by what? M raised to power 4 divided by this one is same thing as what? 8n raised to power minus 2. You get that? So that this 8 can terminate this 64 to be left with 8. Then I'm now left with, that's a number. Then in terms of the letter now, see, I have 8. Now I'm now picking the letters. N is above here, n is at the denominator here. Alright? So from that, I can apply the law of indices. The power here is 1, the power here is minus 3. Because of the division sign, what do? I take one of the bases, then I subtract the power. The power here is 1 minus 2. Do you get that? So that this will now become, then I have times, what about the m? M here is having power 4, m here is having power 3, and there's a division sign. What do? Take one of the bases and subtract the powers, 4 minus 3, so that this will give me 8. Then I'm going to have n raised to power what? 1 plus 2. Then I have n raised to power what? 1. So that if you rearrange, 1 plus 2 is going to give me what? 3. Then this will now eventually give me what? 8m n raised to power 3, arranging them alphabetical order. So which one of the, okay, that means it's still the same thing as writing as 8n3m. So which is option D. I hope that is clear now. Hope it's clear. So how do we solve this problem? Solution now. There are two different bases. So how do you do it? That means you are going to simplify them one after the other. Okay? You cannot combine this because the bases are not the same. You cannot use the addition law of logarithm here. So we can handle them individually. So we have log 128 base 8 plus log 9 base 3. So this is going to be written, this 128, I can write it as what? An index notation to base 2. I hope you know that. So that will give me 2 raised to power what? What do you think it is? That's 2 raised to power 7. Because 2 times 2, that's 4, times 2, 8, times 2, 16. times another 2. Is that not 32? That's 5 now. Times another 2. Is that not 64? That's 6. Times another 2. Is that not 128? That's 7. So then 8 is same thing as 2 raised to power 3. Now plus, I can write this as log, this is same thing as 3 raised to power 2, then I have 3. So now I'm not going to recall which of the laws of logarithm will be applicable here. Now recall here that log a raised to power b base c, this is same thing as what? B log a base c. This index here can become a coefficient. Alright? Now, but if it were to be both numerator and denominator, for example, log a raised to power b base c raised to power d, what would that happen? It will be the same thing. This b becomes a coefficient here, b, and this power here, the index here also comes to this side and becomes a divisor, so that you have b over d, then you have log a base c. So the same way, so this is going to become 7 over 3 log 2 base 2, plus this will become 2 log 3 base 3. Alright, so that this will now become, what is log a base a going to give you? You remember it is 1. The same way, 7 over 3 times 1 plus 2 times 1. So that this will be 7 over 3 plus 2. Okay, and your LCM here is what? 3. 3 in 3 is what? 1. 1 times 7. Is that not 7? Plus this same thing as over 1. 1 in 3. That's 3. 3 times 2. That's 6. If you add them together, what do you have? You have 13 over 3. Do we have an option there? Oh, I made mistake in my options. Option A is 19. Sorry, I made the mistake of option B is 48. Option C is 13 over 3. Option D is 6. Sorry, those values are for the other option. So you see that that's option C. Alright. So the last part, that's question 4. It says find the value of y if tó bá jẹ́ wípé 1 over 2 log y base 3 is equal to what? 2. So option A 9, option B 18, option C 9 over 2, option D 81. Do you need to panic? No. Solution. So what do? We have 1 over 2 log y base 3 equal to 2. Alright? So what do here? I can multiply both sides by 1 over 2 so as to terminate this. If you like, you can take it here so that it will become an index of y, but permit me to multiply both sides. So this will become log y base 3 equal to what? 2 times 2. Okay, once you multiply both sides by 2, it will terminate this, then you have this. So this will become log y base 3 equal to what? 4. And I can convert this to an indicial equation now, or indices. That means from here, my y is going to be equal to 3 raised to power 4. Okay, the base carries this. And what is 3 raised to power 4? 81. That's option D. Alright, so you can see that it is very simple. Okay, and I think, okay, 2013, they gave us another question on indices and logarithm. So let's quickly look at that. 2013 question 18, we're asked to simplify log x raised to power 4 base x plus log 4 raised to power x base 4. It's very simple. In fact, you don't need to touch anything, but no problem. Look at how we solve it. X raised to power 4 base x plus log 4 raised to power x base 4. From your law of logarithm, you know that this can become what? 4 log x base x. This 4 can become a coefficient. Plus then this x will become a coefficient. You have this, okay? So that what do you have? 4 multiplied by log x base x is 1 plus log 4 base 4 is also 1. So that 4 times 1, what do you have? 4 plus x times 1, you have x. 4 is a number and x is a letter. So 4 plus x is 4 plus x. You can't add it, okay, because they are not like terms. So the result here is C. If you multiply, you go and pick option A. And you have to be very careful. Alright. And the last but not the least for OAU 2013, that's question 19. It says solve the equation 3 raised to power x plus 1 equal to 27 raised to power. Okay, so we have 3 raised to power x plus 1 equal to 27 raised to power 1 minus x. So our duty is to look for a way to rewrite this 27 as a form of base 3. So I have this, then 27 is same thing as 3 raised to power 3 into 1 minus x. So what do I do? The two powers will multiply. So I have what? 3 raised to power 3 times 1 is 3, then 3 times minus x is minus 3x. So we have this. So here, you notice that the bases are the same. I can infer or imply that the powers will be the same. Don't forget, not 3 cancel 3. So I'm going to have x plus 1 is equal to what? 3 minus 3x. The simple reason is because the bases are the same. So from here I can say that I can solve the equation so that my x minus 3x, when it is added to both sides, it will look like this one comes to this side, then it becomes this. Then I have 3. When you subtract 1 from both sides, it will look like this minus 1 comes here to become negative, so that this will become 4x, then this will become what? 2. And now to look for x, divide both sides by 4, x becomes what? 2 over 4, and that's what? 1 over 2. Do you see that? Option A. Okay, so it's as easy as that, and that's for Ife. Alright, I hope you have been able to pick one or two things from what we've done from those institutions. We still have more institutions to check. So, but from this that you have picked, I declare that this knowledge is retained in your cerebrum in the name of Jesus. And when you will need this application in the exam hall, may you be able to recall them and apply them appropriately without any form of error in the name of Jesus. Please ensure that you maximize your time to read and prepare for this exam, and God will help you.